Okay, we're going to be talking about building this chair over the next couple of videos. First, a little bit about the design. It's actually a counter height chair, just because that's the height of my bar. An actual bar height would be 6 inches taller. One thing about the design is it's got a low back, and the idea of a low back is that you can then still access your countertop. This is a countertop we use for a lot of things besides a bar. This lets you get to it without it being in the way if it was up here. Plus, when you swivel it, it won't ram into the bar top, which is kind of nice. It's obviously a swivel chair. It's got this nice scoop seat. We've got an inlay in the backrest that we'll talk about. And it's got a curved backrest there. The backrest supports are put in with Maloof joints, which we'll talk about making those. The legs are compound angle legs, and those are put together with some angled loose mortise and tenons that we'll talk about, and a few other things along the way. Okay, well, here are the two pieces of a Maloof joint, the female part and the male part here. And of course they go together like this. And it makes for a very, very strong joint because there's really three different parts that interlock together. Pull it apart here. First, you've got the width of this piece here exactly matches the width of the main channel, here. And then the width of the center part here exactly matches the width of this center part. So those are two different parts that have a really tight fit. And then lastly, the width here of these two tabs sticking out exactly fit the width between these two tabs. And so it kind of locks in three different ways, and so it makes a very strong joint. In terms of making the joint, on this piece, it starts out when you first just cut a dado, the width of this center part, you cut the dado all the way through, and then you come through with a rabbiting bit, and you route out a rabbet on the front, and you route out a rabbet on the bottom. And then, and maybe to me one of the cleverest parts is that on this piece, you take a round over bit and you round the front edge with a round over bit. And the key thing is that this round over bit, in this case, this has a 3/8 inch radius round over bit. It exactly matches the radius of the rabbiting bit. So, for example, you can kind of see that here. This rabbiting bit that I use exactly matches the radius here. Okay, well, can you see that? That these two have the exact same radius, and that's why the two parts match perfectly when you're shoving them together here. This radius here exactly fits there. Now you can use any size bits, and actually the standard Maloof joint that he uses in his chairs is about twice the size of these. But in this case I used a 3/8 inch round over, and then I used this rabbiting bit, which is actually a 3/16 inch rabbiting bit, but it has a radius of 3/8 inch, just like the round over bit. And that's about it. So we'll show you kind of the steps on cutting one of these. Okay, and here's our starting point for cutting the Maloof joint. It's basically a block of wood about 18 inches square, about 2 inches thick. I've got the seat drawn on there, and we're going to first cut the joints in the seat before we cut out the seat at all. Okay, here we're getting ready to cut the first dado in the seat for the Maloof joint. You can see that I've got the stock clamped to a tall fence that's attached to my miter gauge, and I'm using a large 12-inch C-clamp that I purchased from Harbor Freight for only about $15, and I find it to be very handy for certain situations like this. You'll notice also that there's already some dados cut into the waist areas of the seat stock, and you'll see that we're going to use these later to do some test cuts as we dial in settings for some of the subsequent cuts that we have to make. And then here you can see that we've completed the first dado in 2 passes. Okay, now this photo shows the back side of the tall fence that I'm using on my miter gauge. It looks a bit strange, but that's because it's a board I use for a variety of different things. Most commonly, I actually use it on my router table in conjunction with router templates, but here I've simply repurposed it to use as a tall fence. And you can see it has a bunch of those dovetail slots in it that I use in conjunction with the dovetail clamps from Micro Jig to simply clamp it easily to my miter gauge. Okay, now you might have noticed that I cut the dado joint at 9-degree angle, and you might be wondering why. Well, that certainly isn't required for a Maloof joint at all, but it is required for the design of my chair backrest. My backrest design, which we really haven't discussed yet, is curved with a radius of 22 inches, and that curvature was picked based on some other chair examples I looked at. This sketch shows how I calculated the need for a 9-degree angle. My backrest support posts are spaced 7 inches apart, and the circle associated with a 22-inch radius curve has a circumference of 138 inches, based on the formula that the circumference equals 2 times pi times the radius. Since my support posts are only 7 inches apart, they take up only a tiny fraction of that 138-inch circumference of the circle. And if you take 7 inches divided by the circumference of 138 inches times 360 degrees for a full circle, that gives me an angle of 18 degrees, which I split between the two posts, with one facing 9 degrees to the left and the other facing 90 degrees to the right. And those angles will now let them exactly match that 22-inch radius curvature of the backrest, which you'll see that backrest coming up. Now, if my backrest was simply a flat board, which wouldn't be terribly comfortable, but then the dados would not be cut at an angle, but instead just be cut exactly perpendicular. Now here I'm getting ready to cut the second dado. To get the proper angle in the opposite direction, I actually have to flip the seat around and cut the second dado from the back side of the seat. Now, if you're watching carefully, you might have noticed that the test dados you saw previously are now missing. Well, that's simply because I was actually building two chairs simultaneously and mixed and matched videos from the two different chairs. But here you can see I decided I could simply cut the dado in one pass this time by simply feeding fairly slowly. Okay, now here's a picture of the final piece after I cut the dados. You can see the two primary dados cut there, and then there's actually 4 different test dados. Again, they're in the waist areas, which I will use in some of the upcoming steps. Now here I'm cutting a test rabbet in one of the test dados. And I'm not worried about the exact depth of the rabbet here yet, but just want to get the exact width of the combined dado plus rabbet, which should be 1 1/8 inches based on the 3/4 inch dado size plus a 3/16 inch rabbet on each side. I've surfaced the stock for the backrest supports to a thickness that exactly matches the rabbeted test dado width. Now here I'm adding the 3/8 inch roundover to the front edge of the backrest stock that we just surfaced to the right thickness. And now I'm simply testing the fit of the round-overed backrest stock in the rabbeted test dado. Now the next step is to dial in the depth of the dado on the backrest stock to exactly fit the narrow 3/4 inch wide portion of the rabbeted test dado in the seat stock. Now to do this, I'm using a piece of test stock that was machined to the exact thickness of the backrest stock. Well, now that we've dialed in the dado depth, we'll go ahead and cut the dados on the actual backrest stock here. And first we'll cut a dado on each side, and then finally we will also cut a dado along the front edge. And now you might be wondering why this backrest stock seems so long, but that's simply because the two backrest supports are combined at this point, and I will split them at the end. Okay, then the last setting that we have to do is to set the depth of this cut. So again, this was a test dado we did, and we didn't worry about the depth the first time. And we made it a little bit deeper than it needed to be, and therefore the width of this, as you can see, it's a little bit too skinny. It doesn't fit. What we want to do is set the depth here, which we'll cut on both of the ends on the new test dado, so that this width of this tang here fits exactly the width here, which is 3/4 of an inch. So that's what we're going to do next. Well, I did a couple of trials then to dial in the rabbet depth, and I'm not showing that here, but here's the final test fit result. And so now that I've got that dialed in, I'm ready to cut the actual rabbets on the actual dados, and that'll be the last step. Well, I managed to lose the video of me actually cutting the final rabbets, but I think you've got the idea by now. Here's a photo of the final result, and the next photo shows the result with the backrest support inserted in. And then pretty soon, the next step will be shaping those backrest supports.